Hey, what's going on, guys? It's Ian here. Today we're going to be talking about the difference quotient with y'all. We're going to be talking about what it is, why exactly this thing came up, and hopefully we're going to make your lives easier on it. We don't want to be wasting too much time suffering on this. It's really not that bad. So, let's get into it. Alright, so if we're really going to understand the difference quotient, the first thing that we have to understand are actually functions themselves. So, if you see right here, I got a pretty good function up for us. It's f of x equals x squared plus 2x. And all this really means is if I give you an x, you can plug it in and get another value out. Usually we think of that as y. Now unfortunately, this notation is really confusing for us sometimes. What's a better way to think about it might be something like this. What if instead of an x, we put a star right here? And we do the exact same thing over here. So right here we replace the x with a star squared, and over here we replace this x with a star squared. Now you might be thinking to yourself, Ian, I'm not a 2-year-old. I can do the pattern game. Yes, that's what we're going for. So up here we have x's. These can be confusing, but really this is what we mean by functions. We just mean that whatever you put in here, go ahead and copy paste it right where you see it. So the pattern game actually is effective in this case. For instance, we might be used to this one. What if, in this problem right here, I said, find f of 2. Well, you might be thinking, okay, all we do right there is just plug in 2 for x. You're exactly right. So that's what we're going to do. We get 2 squared plus 2 times 2. Wow, a lot of 2's in this one. And from there we can simplify it out. We get 4 plus 4. Last but not least, we get 8. The point of this being, why do you ask this? What we do with a 2, when we have the 2 on the inside of the parentheses, we copy paste that 2 wherever we see an x. Or in this case, a star. Let's move on to something a little more complicated. How about f of 2 plus h? Draw a little line right there. In this case, we treat it the exact same way. 2 plus h is in place for star now. It's inside the parentheses. So all I do is I copy paste whatever's inside the star where I see the other stars. So in this case right here, I copy paste 2 plus h, parenthesis, wherever I see that star. 2 plus h squared plus 2, oh, another star, times 2 plus h. From there we can simplify this out, but we really want to get used to this notation right here. Last but not least, let's try something incredibly complicated. F of x plus h. It's really not that bad, I was just kind of souping it up. Remember our star notation if that helps. So, one thing we can do, since x plus h is on the inside of the parentheses, all we do is copy paste this wherever we saw a star in our original function, wherever we see that x, which would be a star. So if it helps, remember, think about it this way. Let's do it. So, x plus h is on the inside, put that where the star is. X plus h squared plus 2, that stuff's not changing. Oh, another star, copy paste x plus h. From there we go ahead and simplify. We'll save that for just a little bit. But first, I want to give us a little historical insight into where this thing actually comes from, where the difference quotient actually makes its debut in history. And in order to do this, what we're really going to look at is just a graph of a function. Now notice I don't have a name for this function, we're just going to call it f of x. I don't really have a rule for this function yet. We don't know that yet. That's no big deal. So, a common question in mathematics is if I take 2 points, maybe x equals 2 right here, and let's say I go all the way out to x equals 8, something like that. Now, because I have a function, they're going to have a y value on this function. And that can be found by just plugging in the points 2 to my function. So it has a y value of f of 2, and 8 to my function. This has a y value of f of 8. A common question in mathematics, as I was getting at, is can I find the slope between the 2 points? If you're more physics related, you might have heard this as, can I find the average rate of change? Now, if we're going to find the slope between 2 points, what we typically do is consider that the slope of this here green line. So, in order to find the slope of that line, you guys might be familiar with this formula, hopefully. All we do is this right here. M, which stands for slope, is going to be change in y over change in x. So, what that could be, in this case, would be f of 8, the y value right here, minus f of 2, the y value over there, all divided by the numbers that are on the inside. 8 minus 2. In this case, because I didn't give us a rule, that's all we could really do in this case. So that would be our slope. Alright, now that we're used to the operation of this type of thing, where we can find the slope between these 2 points, let's get a little bit more general with it. What do you mean? Well, here's what we're going to do. Instead of having a 2 right here and an 8 right here, what instead we're going to ask is, what if my first point is just x? That way it can be anything. That's kind of the beauty of it. Well, if we were to find a y value for x, all we do is plug in x to our function. And we actually kind of get something silly when we land on that. We just get f of x back. That's all it is. Now, a question could be, from x, wherever you picked an x, you threw a dart and you landed on an x. What if I walked to the left or to the right, whichever your way is, what if I walked over h steps? So the distance between here and this next point is h. Well, since we picked out an x already, and we walked over h, the point we would land on would be x plus h. So x plus h is an actual point right now. If we wanted to get a y value for that, what we could do is plug in x plus h to our function and we get f of x plus h. And now that slope formula becomes something different. If we were to find the slope of it, go back to the orange marker, the slope between these 2 points, we'd have to take the first y value, or excuse me, the second one, f of x plus h, minus the second y value, minus f of x. All divided by the first x value, which is x plus h, the point x plus h, minus the second, or the first x value. I'm getting them all confused. Minus x. Now, if we did a little bit of simplifying, the top we can't really simplify just yet until we have a rule for the function. So I'll leave that be. However, the bottom part, x plus h minus x, the x's are going to actually cancel for us. So we got a boom, boom going on. And what we'll end up with on the bottom is f of x plus h minus f of x all divided by h. And this right here is going to be our difference quotient. So this is where it comes from. Just fine as a slope between 2 points, where your 2 points are admittedly a little weird. Okay, now for everybody's favorite math question of all time. Given a function f of x, and this one we got a relatively simple function, the function being 2x plus 4. What they'll tell you is to find and simplify the difference quotient f of x plus h minus f of x all over h. Now, if you're still not comfortable with this notation, try to go back and play with some of those examples from when we first started off talking about function notation. How these guys are really just plug in the pattern. It's that 3-year-old game, remember? Everybody can do this one. From here, what I wanted to notice is this is actually 3 different parts right here. What we really have going on is the function f of x plus h. Remember, that's just f, with x plus h copy pasted wherever we see an x, minus the entire function f of x, all divided by h. And that's how we're going to attack it. I typically like to draw parentheses. It helps organize my mind. So, the first question we can ask, what is f of x plus h in this case? Well, remember the star game. If we were to replace x with a star right here, what we'd find is something like this. The function now is just 2 times whatever's on the inside plus 4. So therefore, f of x plus h is just 2 times whatever's on the inside, in this case x plus h, plus 4. And that's it. That's all we got right there. We're done on that part. So now we plug it in with our red brackets here. So we're going to have a 2x plus h plus 4, first bracket, donezo. Now we're going to copy that minus. Don't forget that part. One of the most common mistakes on this problem is to forget the minus and forget these parentheses right here. That begs the question, what's on the inside of the parentheses? The entire function f of x. So all we have now is 2x plus 4. That's just your original function every time. So this is the easiest part, as long as you remember the parentheses or the brackets. Yes, we just get a copy paste. All divided by h. Don't forget that part either. It's kind of sneaky, that little h. From here, all that's left to do is simplify the top and hopefully cancel out an h. You'll see that that's a hallmark of this problem. So a couple things we can do here. One, we can distribute this 2 in. That'll net us a 2x plus 2h plus 4. Another thing we can do is distribute the negative. Minus 2x minus 4. All divided by h still. Now we're in a pretty good spot. And we're going to break out the red marker just because it's super fun to do when we're canceling. If you notice, I have a 2x right here and a negative 2x. Cancel, cancel. I have a plus 4 and a minus 4 right here. Cancel, cancel. And what we're left with is just a 2h on the top divided by an h. Last step right here, notice that since we have an h on top and on bottom, we can cancel both. Boom, boom. And all we're left with for an answer in this case is just 2. So, a couple hallmarks to this problem, a couple key things I like to focus in on. Step 1, make sure we get f of x plus h right. Always double check that one. Remember, you're just plugging in x plus h wherever you see an x. It's just by this pattern game. Second one, make sure you have parentheses on the outside of your second function right here. And that's because we're going to distribute the negative down here. It's a sad, tragic mistake when we just have the negative on the first one, because then we won't get everything canceling that we want to. The third thing I like to focus on is actually this step right here. If you did those 2 steps right, and you did all of your algebra correct along the way, you'll always get to a point where you can cancel an h out, the bottom h in particular. And that's going to be your kind of check. So if you can't do that, probably go back. You might have done something wrong, but that's no big deal. We're getting used to this, and hopefully it's feeling pretty good right now. Alright, let's try a slightly harder function right now. That way we can really get to know this process. Remember, if you're not challenged by an easier problem, try to find the point where you are challenged. That's the only way you're going to learn and improve on your skills. What I'm thinking is a good step up would be to throw a negative in and make it a fraction. Yeah, we love fractions. And remember, the problem's going to say something like this. Find and simplify the difference quotient, which is f of x plus h minus f of x all divided by h. And in this case, I like to do parentheses. I highly recommend them. They just kind of help keep you organized. Parentheses never hurt anybody, right? Okay, so here we go. First step first. Let's start right here. Find f of x plus h. F of x plus h. Remember, all that is, by that pattern game, is copy pasting x plus h in wherever you see an x in the original function. In this case, we only have to do it once. It's kind of lucky. Negative 1 divided by, oh, there's an x. So we copy paste x plus h. That's all our f of x plus h is in this case. So go ahead and plug it in over here. Negative 1 divided by x plus h. Minus the entire function. I'll go ahead and keep up with my parentheses here. Just to show you I'm really just kind of substituting in. Minus the entire function f of x. Well, all that is this guy right here. Go ahead and just plug it in. Minus 1 over x. All divided by h. So, from here, our job is to get to a point where we can cancel out an h. Remember, that's always going to happen. So one thing we can do is start working with the top. The top's the nasty part here. We can't really simplify the bottom until the top is simplified. So always focus on that numerator. Equals. Let's go ahead and take care of these negatives. That way we can drop the parentheses. Negative 1 over x plus h. Negative negative leads to a positive. So plus 1 over x all divided by h. So in this case, it's our job to simplify that top. Well, we're adding fractions right here. So what we really need to do that is a common denominator. Now, if you can't think of a slick one, and that's no problem if you can't, the easiest one, and the only one that's going to work for us right here, well, the nicest one anyway, is going to be just multiply the two bottom ones together. So x times x plus h is going to be our common denominator here. How do we get that on each side? Well, multiply on top and bottom by the thing you don't have. What am I talking about? So over here, I want x times x plus h on the bottom. That's going to be a good common denominator. I'm missing that first x. So what I'll multiply by, pardon me, I'll multiply by an x on both top and bottom. My marker's dying. Over here, I'm missing the x plus h, so in a similar way, I'll multiply by x plus h on both top and bottom. And that'll do the trick for us. Because now, when we go to simplify our functions by actually doing this multiplication, over here I'll have negative x times x plus h, divided by, plus x plus h, all over x times x plus h, all divided by h. Now we're in a good spot to add these fractions together. When we add them together, what we'll end up getting is negative x plus h divided by x times x plus h, all divided by h. We got some canceling we can do. These x's are going to cancel for us. Yes. So what we really have right here is h divided by x times x plus h, all divided by h. Now, we have a nice shortcut that we can do here. We can actually just suck up this h to the denominator of the top function. What's really going on though, and this is a better observation, is that, hey, I have two fractions right here. Fraction number 1, this guy, the top one, and fraction number 2 is a little bit hidden fraction. It's h divided by 1. Now if I were to divide these two fractions, remember our rule is you copy the top one, divided by x times x plus h, and I would flip the bottom one, times 1 over h. And now these guys will cancel for us. So last but not least, if I may, bring it up here a little bit. Our answer, therefore, will be 1 divided by x times x plus h. Or, if your teacher likes you to simplify beyond this, 1 over x squared plus xh. Box it, marker drop. We're done. Hey guys, thanks for tuning in today. Hopefully we really made those difference quotients a little less scary for you. I wanted to end today on some important notes, as always. So, first step, if you're having problems with f of x plus h, as is common, remember the pattern game. So remember that f of x equaling something like x squared plus 2x really means that f of whatever's on the inside, let's say star, all you do to this number, star, or thing, is square it and then plus 2 times it. Okay, this is a little bit more clear about what we're really getting at with this function stuff. So, remember the pattern game if that was a trouble to you. Step 2, when we're actually going to simplifying the difference quotients, what we can do is know your checkpoints. So, what are your checkpoints? Checkpoint number 1, is f of x plus h correct? It's always worth to double check that we actually played this pattern game correctly and plugged in x plus h in the correct manner. Step 2, did I distribute the negative? So, as you remember, once we found f of x plus h, we had to subtract f of x from it. Remember that you're subtracting the whole function, so you will have a negative that will distribute for you. Step 3, if you did these two correct, hopefully you're going to have an h cancel. That h on the bottom has to go. That is the last checkpoint. And if that doesn't happen, and it has to go in a legal manner, then we better check steps 1 and 2. And if those are correct, just some algebra along the way.